All right, I'm going to get started. Hopefully people will be trickling in a little bit. So today we're going to talk about core subjects EC6 math and specifically probability and statistics, which is competency 5. I've noticed that's the competency that seems to get the trickiest for most people. So let's get started. So everything in my course is based on the competencies, which is what the test covers. So that way it's very authentic, very true to what you'll see on the test. So competency 5 says the teacher knows how students learn mathematical skills and uses that knowledge to design, organize, and implement instruction and assess students' learning. Okay, so we need to know probability and statistics, right? So let's get to some problems because this is to learn about the different types of graphs, but let's look at a sample problem. So one thing that a lot of people don't know how to do is read a stem and leaf plot. So here's a stem and leaf plot. It has a number in the tens column. This represents the tens, and all of these represent the ones. So this is 60, 61, 65, 66, 66. This is 72, 75, 78. And this is 81, 87, 87, 89, 89, 89. So when you see a stem and leaf plot, the main thing to know is that it helps you figure out the mean, median, and mode in a quick way, right? So let's look at this. To find the median, it's easy. You want to find the number that's in the middle. So what you're going to do is cross out the numbers, like one number here and one number there. So if you're just joining us, we're talking about stem and leaf plots, mean, median, and mode. So to read a stem and leaf plot, this is the tens place, and these are all the ones places. So this would represent 60, 61, 65, 66, 66. So each of these is a separate number. So a stem and leaf plot is what we use to quickly calculate mean, median, and mode. So mean is average, median is the number in the middle, and if there's two numbers in the middle, then we average those, and mode is the number that occurs the most often. So we can quickly look at this and see the mode would be 89, right? Because that appears 3 times, whereas 87 is only twice and 66 is only twice. So the mode we can tell just by a quick glance. To find the median, that's the number in the middle. We're going to cross out the one number on each side until we get to the middle. So we would cross out 60 and 98, 61 and 97. And we would keep doing that until we're left with only 87. The average is the one that requires the most work. What you have to do is write all of the numbers out. And you want to count how many there are. So there's 19. Then we have to add all of those numbers up. And remember, you don't get a calculator on the test. So luckily on the test, I don't think you'll get one quite this long, but I want to make sure you know how to do it in my course. So I give you ones that are maybe a little bit more lengthy than what you might see on the test. So you add all of those up and you get 1,535, and then you divide that by 19, because remember, to find the average, you add up all the numbers and then divide by the number of items you have. So there's 19. So the average or the mean is 80.79. So we already found the mean, median, and mode. Makes it really quick and easy. A scatter plot is another visual representation you need to be familiar with that's related to probability and statistics. And what you need to know about a scatter plot is that it shows correlation, relationship. So it's either going to be a positive correlation, in which case the slope of the invisible imaginary line would be positive like this, or negative if it's going down. So if the data points start off high and are mostly going down, then that would be a negative scatter plot. I can show you an example of a negative scatter plot. See how this one would be positive right here, and this one would be negative. Okay, so scatter plot again is used to show correlation. Histograms are like bar graphs, but they show a range of data. So see how down here there's a range of numbers? So it's helpful to visually show data according to a range. A relative frequency table is pretty simple. It just shows how frequently something occurs. So maybe the number of students who had a favorite color, this would represent the frequency chart. And relative frequency would be the percentage, the number of these students divided by the total number. So we have to add the total number is 7 plus 10 plus 3, which is 20. And to find the relative frequency, we would divide the frequency number by the total number, 7 divided by 20, or this one, 10 divided by 20, and we get 50%. Okay, because remember, to find percent, it's out of 100, right? So we divide this and we end up with 0.35, which is 35%. So you would do the long division, 7 divided by 20, and you would get 0.35, which is the same as 35%. And then we have,
They finished.
if you could mute your mic, please. Okay. And then we have a percent bar graph, which shows the percentage of composition. It's kind of like a pie graph. Okay, so that shows different forms of data. I'm going to skip ahead. My course has everything you need to know, but of course in this brief tutoring, I can only cover certain things. But we'll cover simple and compound events because I think that's what gets a lot of people. So a simple event has a single outcome, just one outcome. So for example, if you roll a die and you want to know the probability of getting a 2 or a 3, that's a simple event. And what you would do is just divide the number of desired or chosen outcomes by the total number of outcomes, okay? So in this case, that there's 2 chances, right? There's 2 possible outcomes that we're looking for, a 2 or a 3. So 1, 2, and there's 6 sides on a die, right? So there's 6 possible outcomes. So the probability of rolling a 2 or a 3 is 2 divided by 6, okay? And then if you want to represent it as a decimal, you would do the long division, right? So simple events are pretty easy to calculate. You just take the sample, the possible outcomes that you're looking for, not the possible, I'm sorry, you took the desired outcome divided by the total number of outcomes, okay? So for example, if you're rolling a die, tossing a coin, and you want to know the probability of getting heads, well, if it's not a weighted coin, as long as it's a normal coin, you have equal probability of each, right? So if you want to get heads, there's one heads, and there's only 2 sides. So it'd be 1 divided by 2, or 0.5. A compound event gets a little bit trickier. That's when there's 2 or more outcomes, like the probability of drawing a king in a deck of cards and rolling a 3 on a die is a compound event. So let's look at that. So the probability of, let's look at this one. This one's a little bit easier to start out. So we'll start with something easier. If we want to find the probability of rolling a 6 and landing on heads, what we would do is we would say, okay, I know the probability of rolling a 6 is 1 out of 6. Remember, that was like a simple one that we did earlier. There's 1 6 on the die, and there's 6 possible outcomes, 1, 2, 3, 4, 5, 6. So the probability of this is 1 divided by 6. The probability of landing on heads is 1 divided by 2 that we already did, right? So now to find the probability of a compound event, we multiply those 2 numbers. We have 1/6 times 1/2, and our answer is 0.083333. So the probability of both of those events, rolling a 6 on a die and landing on heads when tossing a coin, is 0.0833. Okay, or 0.08333. That's the probability. Okay, so if you wanted to say it as a percent, it would be an 8.3% chance, right? So that's simple and compound. Sample spaces, you do need to know how to work out sample spaces. So let's look at this. For tossing a coin, it's super easy. There's only 2 possible outcomes, right? So the sample space is just heads and tails, right? Now it gets trickier when there's 2 or more events, right? When it's a compound event. So the problem that we just did, rolling a 6 and landing on heads, here's all the possible outcomes. We could roll a 1, 2, 3, 4, 5, 6 and get a heads each time, right? Or we could roll a 1, 2, 3, 4, 5, 6 and get a tails each time. So see how there's 12 possible outcomes. 6 plus 6 is 12, right? So there's 12 possible outcomes. So that means that if we wanted to know the probability of rolling a 1 and getting heads, our probability would be 1 divided by 12. There's only one of these situations. The probability of getting a 1 and anything would be 2 out of 12, right? Because there's 2 of these, 2 out of 12. The probability of getting a 1 and a heads or a 1 and a tails here, right? 2 out of 12. So you just, whatever they present you with, you count how many of those desired outcomes there are. Like if they said, what's the probability of getting a 1 and a heads or a 6 and a tails? Well, that's 1, 2 divided by 12. Okay, so another way to do this is this type of diagram right here, a tree diagram. Okay, so what's the probability of rolling a 2 on a die and drawing a green marble if there's a bag with a blue, a yellow, and a green marble? Okay, so the probability of rolling a 2 on a die is represented right here, right? And each time you roll a die and then draw a marble, your chances are, your sample space would be blue, yellow, green. But let's look at this one because this is what they're talking about. We have a 2 and a green is what we want. So notice there's only one of these possible outcomes, but how many total outcomes are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 possible outcomes. So it would be 1 divided by 18, right? Another way to do that would say, okay, it's 1 out of 6. This is 1 out of 6, and this is 1 out of 3, right? 1 out of 6 because there's only 1, 2 out of 6 possible outcomes, and 1 out of 3 because there's only 1 green marble out of 3 possible ones. So 1/6 times 1/3 is 1/18. So you could do this one of 2 ways. So this way you could guess and check. So that's the basics on diagrams. My course goes into a lot more detail, but that's the basics. And then let's look at some sample questions because most people want sample questions. But I want to caution you, it's not a good way to study to just take sample questions. It's a good way to check your understanding, but not to study. But because people like it so much, we'll do a couple of sample questions. So a 5th grade class is studying probability. The teacher breaks them up into small groups. Each group is to roll a die 50 times and record how many times a 1, 2, 3, 4, 5, and 6 is rolled. Next, they make a frequency chart and determine the experimental probability of rolling each number. Okay. Then as a class, they share the results on the smartboard. Students know that the theoretical probability of rolling each number is 1/6, but the probability the groups found from their experiment varied greatly from 1/6. Each group had different probabilities for each of the numbers. What is the best explanation for this discrepancy? So you might not know some of these terms in here. So theoretical probability is how it's supposed to work in theory in a perfect world. So we know that because there's 6 sides of a die, and if it's a regular die, it's not weighted, then the probability of each one would be 1 out of 6. So that's in a perfect world, that's how it's supposed to work. But we know that if you roll a die 50 times, you're probably not going to get exactly 1 out of 6. Well, you're not on every single one. That's called the experimental probability, the probability that you're actually performing, that you're doing. So how it works out in real life is not always how it works out in theory, right? What happens though is the more times you do it, the closer it gets to, in theory, to theoretical probability. So the more times you do an experimental probability, the closer that will get to theoretical. So let's look at the best explanation for this discrepancy. A, the students likely recorded their answers incorrectly, resulting in faulty data. There's nothing that indicates that they did anything incorrectly. Okay, so that's not A. B, the students must have incorrectly calculated their experimental probability. There's nothing to indicate that either, that they were incorrect. C, since the number of rolls was limited, 50, the probability is only based on that. If the students rolled the die more times, the probability of rolling each number would be closer to 1/6. This one sounds good. This is what I was talking about. Increasing the number of times you do it will get the experimental probability closer to the theoretical. So it's probably this one, but we always look at this one. Students should try the experiment again, this time rolling the die 10 times, since a smaller sample will result in the experimental probability being closer to the theoretical probability of rolling each number. No. Remember, we want to do it more times for the experimental probability to approach theoretical. So if you get it right, it tells you why it's right. And if you get it wrong, it'll also tell you why, that answer is not correct and why it gets wrong, why the correct answer is correct. So let's look at this. What type of graph, chart, or table would be easiest to quickly determine the mean, median, and mode? You probably remember we just went over that, and it was a stem and leaf plot, right? So that was the one we did where all of the tens were on one side and all of the numbers on the one side represented a unique number. All right. And then let's look at the next one. All right, students are playing a game and must throw a beanbag on the mat above. The object of the game is to throw the beanbag in the red square. Assume the probability of throwing the bag somewhere within the blue circle is 1. What is the probability of throwing the beanbag on the red square? Okay, so here's the red square. The area of the red square, to find area of a square, it's length times width, right? So 2 times 2 is 4 inches squared. But we need to know the probability of it landing on the square versus out of the whole sample space. So the probability of it landing here divided by not the probability, sorry, the area of this divided by the area of the whole thing. Because remember, it's the desired outcome is here and the whole possibility is the circle. So I'm going to open up something where I can show you guys. Second, I've got to open up a board. Okay, and then clear it out. Okay, so we have a circle, that's the whole probability, and we have a square here. And remember, this is 2 by 2, so the area of this right here is 4 inches squared. We already calculated that because it was 2 times 2, 2 inches times 2 inches. So that's 4 inches squared. Now, we need to go back to the course. The radius is 3 inches. See that? So the radius here is 3 inches. Now we have to find the area of the whole circle. Now you do have to memorize this for the test. The area of a circle is pi r squared. Okay, so we have pi r squared. So that's going to be pi times 3 squared, right? Because the radius is 3. So we have 9 pi. Pi is approximately 3.14. You do have to know that for the test. So we have 3.14 times 9. Okay, so on the test, you don't get a calculator, so I'm going to work this out really quickly. 9 times 4 is 36. 9 times 1 is 9 plus 3, 12. 9 times 3 is 27 plus 1 is 28. And then I have to move it back 2 decimal places, right? 1, 2. So here we're with 28.26 inches squared is the area of the circle. So the area of the whole thing, the whole possible outcome is 28.26 inches squared. And the desired outcome, remember, is the square, and that's 4 inches squared. So then to find the probability, we would divide 4 by 28.26. And on the test, you don't get a calculator, so you're going to have to bust out your long division here. 28.26 into 4. Now, I don't want to bore you guys with the long division, so let's look at my course and, well, actually, let's do it. We've got time. Okay, so we have 28.26. And we need to go into 4. So what we're going to do is, see, 28 can't go into 4, right? And it can't go into 40 either. And it, well, of course it can go into 40. I don't know what I was saying there. So we're going to put it, put a decimal here, okay? Because we put a 0 there. So we need a decimal point here. 28 goes into 40 one time. So we have 28 there. And then we have 12 left over, right? And then I'm going to put a 0 right here, 0 right there. This number is close to 30. 30 times 4 is 120. So I know it can go in about 4 times, right? So I'm going to go look at my answers here, my answer choices. And see, this one is the one that is closest to what we were finding, 0.14. So 1400ths. And then it'll tell us that we're right. And it breaks it out for you right here, breaks it down, everything. So I don't have a really, you know, today it's a small, it's just one person that was able to make it because of the time. I know that most people are still working, but do you have any questions, Heidi?
I had to miss that because I normally do inclusion because I teach already, and I've already taken the EC through 6, but I took the 291, and I have accommodation. So when they finally got